Right, so number 1 says a firefighter places a 20-meter long ladder against the side of a burning building at an angle of 70 degrees with the ground. How far is the foot of the ladder from the wall? So first thing you probably want to do with this is come up with some sort of picture. There's a lot of words there, so we want to, and it's not really a word problem per se, it's just a problem that's within a real world context. So they said something about a ladder, so I'm going to draw a ladder. And they said that that ladder, there's my ladder, and they said that that ladder was 20 meters long, so I'm going to put 20 meters there. And it's propped up against the side of a burning building. So here's a building, and here's my building on fire, right? Do you have to draw the flames? No, you don't necessarily have to draw the flames. But even though I'm not necessarily an artist myself, I think it is helpful to come up with a picture of what they're trying to describe in the problem, so that way you know where to put the numbers. Because by drawing the ladder, and when they say the ladder's 20 meters long, I'm like, oh, okay, well, there's my ladder, so that's where the 20 goes. And then the other information they give us here is they say that there's an angle of 70 degrees with the ground. Well, here's the ground, so this must be my 70 degrees. And what they're asking for is how far is the foot of the ladder from the wall. Well, here's the foot, right, because this is the foot right here. There's the base of the ladder. Here's the wall. So if they're saying how far is the foot of the ladder from the wall, they're talking about that distance right there. Now, if drawing the diagram, drawing the pictures kind of distracting for you, you feel it's a little messy, there's nothing wrong with just drawing a regular triangle. Right, so some people drawing the picture that helps. Some people it's maybe distracting. So that's up to you. So that's one of those things that you have to decide whether you feel like that helps you or not. And so I'll kind of show both ways. And then we're making the assumption that this building is perpendicular to the ground, meaning that it forms a 90-degree angle. So again, we're just having to make that assumption. Now, what trigonometry is in general is just the relationship between the sides and angles of a triangle. And the real easy idea here is that if you know a little something about a triangle, you can use the little something you do know to find something that you don't know. So in our case, if I know the side of one of the triangles and I know the angle of one of the triangles here, then I can use that to find one of the sides that I don't know. Now, which trig function do I use? Well, there's three that we'll look at here, and this is right triangle trigonometry. So these are all triangles that have a 90-degree angle. We'll look at some in a minute that don't, but for this problem, this is going to be a right triangle. So we have this thing SOHCAHTOA. It's basically just pairing up the sides of the triangle. So sine, not sin, you haven't done anything wrong yet. So sine is just opposite over hypotenuse, right, opposite side over hypotenuse. And by the way, the opposite side, we should mention this, hypotenuse is always going to be the side that's opposite the right angle. So wherever the right angle is, if you look across, that's going to be your hypotenuse. So for me in this case, that means that this is going to be my hypotenuse. The opposite side is always opposite the angle that you know or that you're going to be looking for. If we don't know what the angle is, we call that theta. That's just a Greek letter. So instead of, like, if we don't know what the side is, maybe we call that x. So here we just use that symbol theta. So wherever the angle is, if you look out across or opposite from that, that's our opposite side. So if I'm here and I look out across, that means that this is my opposite side. And then process of elimination, the adjacent, right? That word adjacent just kind of means next to. So if we think of adjacent, something that's next to, it's the side that's next to the right angle and theta. So there's our right angle, there's theta, the angle. So that would be our adjacent side. Now, so how do we decide which one to use, sine, cosine, or tangent? It depends upon which sides of the triangle are in play in the problem. And what I mean by in play is that they're being used. That it's a side that we either know or that we're looking for. So the adjacent side we're looking for because that's where x is. The hypotenuse we know because that's the 20, that's the ladder. If we talk about the opposite, we actually don't know anything about this side They're not asking about it, so I won't use anything with opposite. So I look at my kind of menu up here, and anything that's got an O in it, I don't know, and I don't care, so I'm not doing anything with an O in it. And so the only trig function that uses adjacent and hypotenuse is going to be cosine. So I'm going to set that up, and I'm going to say cosine of, in this case our angle is 70 degrees, is equal to the adjacent, which is x, over the hypotenuse, which is 20. And so now I just want to solve for x. Well, just go back to algebra 1. You're just trying to get x by himself, so whatever number is over there that's with the x, you want to get rid of it. In algebra, how do we get rid of numbers? Well, we do the inverse operation. We undo. So if this says divided by 20, the opposite of dividing is to multiply, and we multiply by whatever's there. By the way, just kind of as a shortcut, if you ever have a fraction of any kind and you don't want it to be a fraction, just multiply by what's on the bottom, because what will happen, those two things cancel each other out, and now x is by himself and he's no longer a fraction. But just like as with anything in algebra, what you do to one side, you have to do to the other side. So we'd have to multiply that by 20 as well. So what we end up with is 20 times the cosine of 70 degrees. At this point, we've taken it as far as we can by hand. We're going to use the calculator. One thing is make sure, first of all, that you have it set to degrees. So if you click mode, which is at the top left there, you'll see it's set to degrees. If it's not, if it looks like this, then just scroll over to degree and hit enter there. We have two different ways we measure angles. We use radians as a measure, and we use degrees, which radians we'll talk about later. In this case, we're using degrees. So we'll do 20 times cosine of 70, and we get 6.84. So I'll say x is approximately 6.84 meters. We want to make sure that that answer is reasonable, that it's not a crazy answer. If this side is 20, sure, yeah, that could be 6, right? Because you're thinking about this ladder, this long ladder that's being propped up against a wall. So if it's a 20-meter ladder, that would be 6. Sure, that's reasonable. Something that's not reasonable would be if you got a negative number. That doesn't make any sense. This distance isn't negative. If you got like a number like 5 million, that doesn't make any sense. So I always want to make sure that our answer is reasonable. All right, so go ahead and stop here and try number 2.